Hi, today we're talking about properties of logarithms. So there's a few properties and they're really based upon the exponential properties, such as when you multiply, you add. When you divide, you subtract. When you raise to a power, you multiply. And they follow the exact same rules as that, and they're basically called the same thing. So we got the product, quotient, and power property. There is a bunch of shortcuts for it that I will show you for sure. So let's go ahead and start by proving the product property. The product property goes log b of mn equals log b of m plus log b of n. So the way we can prove this, that it's true, there's a few ways to do it. We got to show one side goes with the other. So I'm going to go with, let's go with this side. So I'm going to say x equals log b of mn. First thing I'm going to do is write an exponential. So I'm going to write b to the x equals mn. Okay, so what you do next, there's a trick to this, which is you b log of m times b log of b, b log of b of n. So, and we know we can rewrite this as one thing, is if we, since we're multiplying these exponents, we can just add them. And so since these are both sides are b, we know that equals log b of n plus log b of n. Now, using this is more important than proving it, to be honest with you. So let's go ahead and move to that. Now, this is the easy part. How do we use the properties to expand? The trick you need to remember, if it's multiplying, you add. When it is raised to a power, you multiply. When it's divide, you subtract. So I like to start this with how many bases are there? Well, we have two bases. We have A, we have B. So I'm going to write log 5 of A, log 5 of B. Does A have an exponent? Yeah, it has 2. So throw it in front. Does B have an exponent? Yeah, 7. Is there anything on the bottom? No. So these are both positive. And that's how you expand it. It's real easy. So basically, once again, any base, that's how many logs you're going to write with the A's and the B's. And then whatever exponent is goes in front. Since there is no fractions, they're all positive. In other words, they're all on top. If they're on bottom, they're negative. Go ahead and try this problem. So how do we expand this? I have ln here. So I have two bases here. I have ln of 25 and ln of 3. They have no exponents, so we don't have to worry about that. Since 25 is on top, it's positive. Since 3 is on bottom, it's negative. That's how you expand it when it's a fraction like that. Go ahead and try this one. Try this one. Okay, now how do we condense it? How do we make it into one expression? Well, it's pretty easy. So once again, write the log for just one of them. Do you see a minus? The answer is yes. Make a fraction line. So if we look at this is 4 log m, so it's positive. So m4 on top. 3 log n is positive, so n3 on top. Negative p, so p is on the bottom. And that's it. That's all you do. So if you ever see a negative, make a fraction. Go ahead and try this one. Try this one. Try this one. Okay, so we're going to do it again. Write as a single logarithm. So once again, there's a minus there, so I write ln with a line. Now I write 2 to the third and 5 to the second power. That's it. Which you can rewrite as 8 over 25 if you wish. Go ahead and try this problem. All right, one more property we have is called the change of base. So how can we use base 10 logarithms to evaluate base 2? Well, if we think about this, right, let's say log 2 to the 8th, which we know is 3. So let's set that equal to some variable. We'll call it y. If we solve this, we get 2, we base 2 both sides. So we get 2 to the y equals 8. And from here, we can just regular log both sides. And so now we can move the y in front, because that's the property. So y log 2 equals log of 8 divided. So we get log of 8 over log of 2. This is called the change of base formula. If you notice, the one on top is the big number. This small number goes on the bottom. So this is called the change of base formula, and that's how they came up with it. So go ahead and try this problem with it.